Hey folks, I'm Pratham. I'm an engineer working on data governance at LinkedIn, and I've also had the pleasure to work in the Trino community previously. And I have Ram with me. He works on Trino at LinkedIn, and today we are going to talk about policy enforcement in Trino. So let's start with the problem statement. So what is policy enforcement? So in the recent years, there has been an increase in the data protection regulations that have been coming up in different parts of the world. So you must have heard of regulations like GDPR, DMA, CCPA, fair lending laws, and so on. And at the same time, the demand of deriving insights from data is not going down. So companies and organizations have more and more data, and they also have the capability to process all of that data faster, uh, especially due to advancements in technologies like Trino. And now it is kind of difficult to balance these both together. So the problem that we saw at LinkedIn was that it was hard for data engineering teams, even like ML training teams, to be able to process this data and derive insights effectively while making sure that they are compliant with every new regulation that comes up. So today we are going to dive deeper into this particular problem, talk about how we approach it, and then also discuss how that is integrated with Trino at LinkedIn. So let's talk about the core concepts first when it comes to policy enforcement at LinkedIn. So the first important part is member preferences. So LinkedIn actually exposes granular privacy settings to its more than 1 billion members. And these settings provide users with control over how their data is processed by LinkedIn. Secondly, this data, when it is collected and then it goes to data warehouse of LinkedIn, like the data is labeled and then um, being accessed through table formats like Iceberg and Hive. And lastly, we have this purpose limitation principle. So this is something that was introduced by GDPR, and it says that the data collected from member subjects, data subjects, which is members in LinkedIn's case, should be collected only for a specific purpose, and then it should only be used for purposes that are compatible with that original purpose. So whenever data is processed, we need to make sure that this principle is honored. And for this particular talk, we will focus on data being accessed through engines like Trino and Spark. So with these concepts, actually, this is an example of member preferences. So if you go in your LinkedIn account, like you will be able to see these knobs where you can go and control what kind of information on your profile can be used for what purposes and features at LinkedIn. Moving on, let's talk about how this works. So we refer to this solution as data guard. So let's take an example first. So on the left hand side, you see this orange colored table, which has three columns: ID, education, and employer. So ID is the member ID, and then we have these two other details about the member. On the top, we have this special table called member settings. So it has the same preferences that we discussed earlier in terms of what data is allowed to be or consented to be processed by the members. So the first two columns indicate the use for ads purpose, and the last two columns indicate the use for jobs purpose. The specific features that we talk about here are education and employer. So as you see, for the member 1 to 3, they have consented to being data being used for ads, but not for jobs. And 2, 3, 4 is they have consented for jobs, but not for ads. So the goal here of data guard is that when the data is being accessed for jobs purpose, the values for user 1 to 3 should be nullified or masked. And similarly, if it is accessed for edge purpose, then the data for the second member should be redacted. So this is what we need to have as a final state. So now let's talk about how it works. So essentially, DataGuard uses the interface of data masking views for policy enforcement. So behind the scenes, it creates purpose-specific data masking views on tables, and then they can be accessed through query engines like Trino and Spark, or something else that supports views. Now, on the right-hand side in the figure, you can see the two important components on the top. One is the policy catalog, and the second one is the metadata catalog. So policy catalog stores all the policies that can be written using collaboration with like legal teams. And on the right hand side in the metadata catalog, you see data labels. So they are also like either can be done in an automated way or can be verified by the table producer. So for example, the table producer can say that the T1.column1 is employer, T1.column2 is education, and so on. So using these two sources of information, DataGuard can like compile these policies, and given a table T1, it can generate purpose-specific views for them and push them to the same metastore. So this is just an example for table one, but the DataGuard takes care of doing this for all the tables that are registered with DataGuard. And more importantly, these views are also refreshed periodically behind the scenes when there are any changes in the policies in the policy catalog or data labels or even the table schema. So continuing the previous example, let's take a look at what the data masking view looks like. So this is a simplified example. So here, like member profiles table has these three columns, and we have corresponding labels. And we also have the member settings continued from the previous slide. Now, hypothetically, let's say there's a policy that says that data labeled as education should not be used for ads purpose if the user has not consented to it. So in this case, this is what the view will look like for ads purpose. So it lets the ID and column one columns. Um, so actually, yeah, it will let. So let's assume that column one is actually education, and column one is employer, and column two is education. So the data subject ID and the employer column will pass through, but the education column will be redacted if the user has not consented to it. So we use the member settings and member profiles join for doing this, and then derive consents from the member settings table. So one thing to note here is that the view is going to be schema preserving because yeah, from the user perspective, they don't need to actually worry about the implementation details, and they can still see the same schema as table, and they can just replace the view, replace the table with the view. So the mask. Let's now take a look at the masking granularities that is supported by DataGuard. So in this example, we have different layers at which the fields can be redacted. So the primitive column, which is column one, it is just a varchar. So if we want to redact all of that, that is supported through data masking views. Similarly, if we want to have a conditional row filter, that when column one is DEF, remove the whole row, or like we can go at a subcell level in a struct, array, or map column. So if we want to redact things within fields within a struct, or selective elements within arrays, or even map values corresponding to specific keys, that can be done using these kind of views that are created by DataGuard. Now, let's talk about why we use views. So at least for the purpose of enforcement at LinkedIn and the current policies that we have, they can be represented using simple SQL operations like projections, filters, some sort of joins, and if needed, UDFs. And all of this can be easily expressed through views. The second important piece is that the views are portable. Um, what this means is that we once we create the views, they can be executable on multiple engines, and we use the Coral translation layer for doing that. Um, S- Third important thing is they are modular. So as we talked previously, from a user's perspective, they can actually be just a replacement in the script compared to the original table. And lastly, the views that DataGuard maintains, they are all versioned. So we can easily roll out new views. If we discover issue, roll back, and so on. And similarly, like if policies or labels change, it is very easy to update the latest view that people are using. Yeah, so once DataGuard creates these views, as you see in the figure, users can replace the tables with views and then submit the same queries to Trino and Spark. And then they should be able to get data that is compliant. But doing this for a whole organization is not super easy. So now, next, Ram will talk about how we can roll this out at scale to make the workloads compliant.
Thanks, Pratham, for introducing us to data guard and data masking views. So, as Pratham said, the next challenge that we have to tackle is how to roll out data guard views effectively, given their capabilities for ensuring privacy and data protection. Excellent. So, one obvious and straightforward approach is to lead in large-scale migration and force apps and users to adopt these data masking views to apply the policies, which essentially involves replacing every table name with the data masking view name in every script. However, this brute force method is not the best approach, as large-scale migration would be expensive and also slow. Since it involves a lot of manual effort to fix the scripts. As you can see from the query snippet, which requires replacing all the tables accessed. And another problem with using the views directly is that it also risks exposing implementation details in the view names to the users. As the view name might have some info about the policy implementation, which is not preferable. For example, in the simple example, let's say if we start using the data masking views by the user, then the query would now look like select star from ads.member profiles detect PI, which gives the user an idea of what kind of the policy or implementation is being applied and which app is enforcing it. Yeah, we can move on to the next slide. So another problem with this approach is, let's say if existing views are used instead of tables in the application. Now all these existing views have to be updated as well with the data masking views. So this migration is not just about fixing this existing scripts, but also updating all the existing views as well. So and hence, obviously this approach is error prone, and any slip in updation of the script would lead to missing compliance and potential loss in privacy. So let's move on to the next slide. Yeah. So in order to solve this problem in the large scale migration, we came up with an approach called view shift. So view shift is like a plugin that dynamically routes table to data guard views at runtime. So in view shift, the user script remains intact, still referring to the original table. But during execution, the tables are automatically redirected to the corresponding data guard view. For example, let's look at this depiction where the engine attempts to resolve an identifier for a table, such as T1, which originates from the user script. So now this engine interacts with the metadata store and the catalog layer for this purpose, and then the plugin can then transparently returns the corresponding data guard view related to this table. So even though the script is written as shown on the left-hand side, select star from T1, the actual execution simulates as if the user had originally scripted using the data guard view, that is select star from T1 UC1, which is the data masking view. So as you could see, we have Spark as well in the picture, because ViewShift can be integrated in different engines like Trino or Spark to achieve this redirection to the data masking view, because it's cross-engine compatible. And the other main benefits are, users do not need to modify their code to adopt the data masking views. ViewShift transparently replaces the table access with the data guard views, and users and apps continue to use the familiar dataset names. And this also makes sure that the users are not exposed to the policy details. And another main advantage is it also supports upcoming policies, as new views can be introduced and enforced seamlessly, and hence it works for the future regulation as well. Yeah, let's move on. Before looking at how ViewShift is integrated in Trino, let's look at the current state of the Trino's statement analyzer without ViewShift. So when a query is submitted to Trino statement analyzer tries to visit each table in the query, and creates an assigned scope for the table. And after resolving the tables in the query will then be sent for execution. So this is the current state, plain and simple. Let's move on. So the component where we have integrated ViewShift plugin is the statement analyzer. We have added a view redirector, which interacts with the ViewShift plugin to fetch the correct data guard view for execution to achieve compliance. So when a query reaches a Trino statement analyzer, it tries to visit each table. And for each table, we have a different handling for the read and write path. Write is essentially a no op, as any writes would be to the table and no redirections needed. But for the read path, the table is then sent to the view redirector. The first step here is to construct the context, which is primarily the session object that we use, which contains the user account, accessing the table, the app the query originates from, and whatnot. So this context is then used by the getView method, which interacts with the ViewShift plugin. So the two main APIs in the ViewShift plugin is the isViewShift table and getDataGuardView. So the isViewShift table API tries to determine if there's like a mapping between the table with the context provided to a data masking view. If there's no mapping, then no view would be returned, and would result in a no op from the view redirector. But if there's a view mapped to the table and context combination, then the data guard view, the get data guard view API would fetch the right data guard view and returns it back to the view redirector. So now the visit table and the statement analyzer proceeds to create an assigned scope for the data guard view. And from here on, the execution would continue with querying the data guard view rather than the original table. So having seen this, now let's look at the end-to-end flow to understand what happens behind the scenes of ViewShift plugin. Yeah. So in this example, let's say we have a query, select star from member profiles that we saw earlier. Now originating from two different applications, jobs application and ads application. So the query from the jobs app runs with its own user account, jobs account, and while the ads application runs with its account, which let's say ads account. Now this query originating from from two different applications, once it reaches Trino, probably let's move on to the next slide. So once the same query but from two different applications reaches Trino, the statement analyzer tries to visit the table member profiles and figures that it is a read path, and hence sends it to the view redirector to figure out if the table has to be redirected to to any data guard view. Now the view redirector constructs the context, again the session object, and passes it on to the ViewShift plugin. So the ViewShift plugin under the hood tries to interacts with the purpose mapping component to figure out what is the right purpose for this table and the context provided, and figures that the jobs application has to be run under the jobs purpose and ads application has to be run under the ads purpose. So once the purpose is all sorted, Now the plugin interacts with the view mapping component and tries to figure out the right data guard view to use to query in this case. And once the view is returned to the Trino, the jobs.member profiles and ads.member profiles, now the Trino interacts with the metastore to get the contents of the view definition. And here we use the Coral component uh, to translate the view definition to the Trino's dialect so that the Trino can then proceed with executing the query. So as you can see, even though it's the user query was select start from member profile and user still uh, sees this script, under the hood, the view shift the view redirector and the view shift plugin would then redirect this query to the right data guard view transparently. Yeah, we can move on. So lastly, we wanted to talk about the other existing approaches in Trino, like the row filter and column masking, or the table redirection with the view combination, and why we implemented view shift. So the main limitation with these approaches is that they are limited to Trino, while the main advantage we gain from ViewShift is its compatibility with other engines, as LinkedIn has multiple data processing through multiple engines like Spark, Trino, and might potentially have other engines like Flink for processing as well. And we need to achieve compliance in all of these. So ViewShift is like one-stop solution to achieve compliance irrespective of the underlying engines. And that was the main motivation behind this. As for future plans, we wanted to take view redirected to open source, since right now table to view redirection is not possible. And we essentially wanted to discuss with open source community and see if there is value in trying to enrich the current table redirection in Trino with the ViewShift APIs to support this table to view functionality. And yeah, and that's it, I think, from us at LinkedIn. And hope you found this session useful.